Hi, Chris Kuzmal here. We're continuing with our work. We've done Newton's third law technically, but the code and the generality of how we do Newton's third law is not very complete. Right now, we have here in this version of the code on line 14, the embodiment of Newton's third law, which is to say, my force is the opposite of your force, the force on one object. If there was only two objects in the universe, then whatever force is going on one object is exactly the opposite of the force on the other object. That's Newton's third law. That's lovely, and it allows us to have our event loop proceed. But what we would like to do is not have the force necessarily be constant all the time. We don't want the force to be the same necessarily throughout time. We know that forces change. So let's delete this line on line 14 and put it inside the event loop. That shouldn't change anything because the force itself isn't changing in the way that we've implemented things. And so we run now and we see the behavior of our code is exactly the same. So force is now updated within our event loop, but we would like to make our force something that is not always constant. So what I'm going to do is I'm going to compute the force on me to be a function of my position, my position, minus you dot my position. Now the variable name, the field called my position, we recognize suddenly is not such a well-chosen name, since you dot my position is a little hard to digest. We'd rather just say position, not my position. So we're going to go and change that variable a little bit later. But for now, we're just going to have to live with the force being the difference between my position and your position. Okay, well, great. Let's run the code now. This shouldn't be a problem, but it is. It's a huge problem, actually. We find that our positions, and here again, the difference between me and you is a little bit muddled because we designed this code for one object in the universe, and now we have two, and suddenly we're in greater need of empathy within our code and distinction. And so what's being printed out is I am fine, my position is 0, 0.0. That's true for both objects because both objects start off in a position 0, and then the force that we're computing is 0 because their positions are the same, okay? And so the difference between the positions is 0, the force between them is 0, and so the two objects don't move. Okay, well, that's good in its way, but it's not really very interesting. And so what we're going to do is we're going to initialize our position to be somewhat, so me dot my position we're just going to set that equal to 10 outside the loop. So that's an initialization, okay? So now when we run our code, we should see an effect, and indeed, we see I am fine, my position is 10, I am fine, my position is 0. That's me and you, even though we're both saying the exact same phraseology, but one object's at location 10, the other's at location 0, and then my position changes to 15, and your position changes to -5 as a result of the updating of the acceleration, position, and velocity due to my force being a function of my position and your position. My cat seems to be quite excited. Leopard seems to be quite excited today. She's exerting a lot of force in a lot of places and experiencing an equal and opposite reaction, and thus flying around since her mass is much smaller than most of the things that she is interacting with. Anyway, so what we've now done is initialize our position prior to the event loop, and the thing is that that's not very satisfactory on line 16. What we would like to do is to be able to initialize our position when we create an object. And so that involves creating a constructor of the right kind, and we'll do that next time.